Hi, I'm Kevin Johnson. I'm an electrical engineering student at Utah State University, and I've created a signal processing and software-defined radio learning tool. And this tool is both for myself to learn a little bit more about software-defined radios and signal processing. And it's also for other students who are coming along in their junior year and struggling in those signal processing classes with the various different concepts. So this tool helps students to be able to visualize signal processing a little bit easier. And so we'll look at what I did for my project and how I created a software-defined radio and did some signal processing on it. So signal processing is used just kind of as an overview. Signal processing is used for digital and analog communications like radio stations, cell phones. These all communicate using the signal, or the signal processing is how we can detect and calculate how to transmit that communication. It's also used for sending out an electronic signal and then receiving that signal to detect objects for and that can be used, so that's radar, and that's used in military applications as well as autonomous vehicles that are detecting other cars or objects around them on the edge of the road. So there are a lot of applications for signal processing. Even medical imaging uses signal processing. Software-defined radios are radios that do the signal processing for communications inside of software or in a computer, rather than having a big electronic receiver with a bunch of wires, and those can be actually pretty expensive and hard to design. So software-defined radios use just a simple, the most basic hardware receiver to receive a signal that's coming through, being transmitted in the air, and then they send that signal into a computer where the rest of the processing is done. Software-defined radios are less expensive and they're very flexible. You can change the software-defined radio by just changing something in your code or in your program. So they're really big in industry and commercial applications right now, and I wanted to learn more about that. So my project was for my project, I found an RTL-SDR dongle. So that's the receiver. That's the hardware. It's just a tiny little package that receives FM or frequencies. It receives frequencies in basically the kilohertz range, so lower frequencies. And that has a USB port, so I can just plug it into my computer. And then on the other end, I can connect this little antenna. And this SDR dongle, you can find them on Amazon for like $25, so it's very inexpensive. So right now I now have it set up to read in the signals into my computer, and then I need some kind of a tool to do signal processing on my computer. Well, I found that GNU Radio was a very simple tool for both learning about and designing simple or complex signal processing systems or communication systems. GNU Radio allows you to just drag and paste blocks to do signal processing, filtering, demodulation, reading in signals, and sending those out to either a file on the computer or to the audio card. So I didn't actually have to write any code. I just used these blocks, and if I wanted to, I could. GNU Radio also allows you to write your own blocks using Python code. So this is my block diagram. The first thing that I do is I read in the audio, or I read in the signal from the antenna, then I resample that signal, and back here I demodulate that signal to the frequency that I would like to, or the radio frequency that I would like to listen to, and put essentially a baseband at 0 frequencies. That's the one I'll be viewing. Here I can filter it. This is a band pass filter, so it'll cut off low frequencies and high frequencies based on the setting that I give it. And then I send that to another resampler that puts the audio or the received signal in the correct sample rate for my computer's audio card. That way I can actually hear the received signal. So what we're going to do is we're going to listen to an FM radio station. We'll be able to adjust that station, and we'll also be able to change the sample rate that we're listening to the station at, as well as filter out low frequencies and high frequencies, and just see the different effects that can have on the received signal. So let's take a look. We'll run the program here in GNU Radio.
Stations. And from Magoosh, online test prep for exams such as the
So without the antenna, you can see that you can hear just quite a bit of fuzz, and right here is our, I'm going to turn it down, right here is our input signal, and then this is the output after it's filtered. So I'll get to that a little bit more here in a minute, but when I plug that antenna on, or when I connect the antenna, you can see that this green starts to appear. That's a stronger signal that the computer is detecting through the SDR dongle. So I've set up a little GUI here, or user interface, and I can adjust the frequency that we're listening at by just typing in a different demodulation value. So I'm going to do 96.7. That's another local radio station here in Logan. So this is just a country station. And so you can see that signal right here in the middle. That's the one we're listening to. On the side we can see some digital communications. It's probably encrypted, so we won't be able to listen to it, but we can slide over there and just kind of see what that sounds like. Might have slid a little bit too far. So by changing the amount that I'm demodulating, I'm basically shifting my spectrogram and kind of jumping around. So in order to listen to the exact frequency, we'll have to tune into the right frequency, set it at 0. Okay, so enough about that. You can also adjust the volume by changing the gain of the system. And then let's look at low-pass filtering and high-pass filtering. So, sorry, give me just a second. We're going to close it and open it back up. I think I may have messed up my sample rate because it's not sounding really clear. That one sounds better. So I'm picking up this station a lot better, as you can see. It's darker green. So here's the output of the filter. So if I cut off the high frequencies, middle is low, sides are high. You can see right here that this is blue. That means it's cut off. And right now I'm not actually affecting the main audio signal, which is right there in the center. But if I keep cutting off, we should start to hear some effect there. See how it's kind of fading off? Or you can hear how it's kind of fading off. You can still hear it, but it's not as clear as it should be. Now we'll do the low-pass filter. So there's still quite a bit there, but it's kind of cut out those bass, really deep bass signals. And now we can modify the sample rate. Sample rate is really important. If you're off on your sample rate, it can sound really strange. So I'm going to sample, rather than at 2 million samples per second, I'm going to go a little bit lower, and we'll listen to how that sounds. Let's see. Let me change this back down to 91.5.
Weisenberg says the problems added up.
The thing about this case is you have an accumulation of outrageous conduct.
So if we sample a little bit lower,
it's
going to start sounding kind of squeaky.
Very important false evidence, which the government later admitted.
And if we go high, if we sample too high, it's going to sound pretty
no losses.
kind
There
of deep.
was a surplus. Government expert had double counted and made other base mistakes. Lawyer Josh Rainbow.
Full evidence went to the core of the case.
So some interesting things happen when you're not sampling at the right rate. But this just allows you to modify that and kind of see those different effects.
Presenting that false evidence.
Down here we're looking at the input signal, and here is the output signal.
Major surprise.
Friday, August 19th,
So
2016.
we're actually filtering a lot of the higher, really high frequencies, these ones that bounce up quite a bit, and that's why this line is a lot more smooth. And as we cut down those frequencies even more, it should be even more flat. So this is GNU radio, and that's my project. So it's a software-defined radio. It receives the signal on a simple RF receiver, sends it into a computer, and then I can do all the processing just using code blocks. And I hope that this is useful for students who are, again, starting into signal processing classes and trying to learn all the different concepts. GNU Radio it's a Linux-based program, and it's easy to just start playing and processing different signals. I'm really grateful for the electrical engineering department here at Utah State University that has supported me in my education as well as during this project, just giving me, helping me with the basic concepts, and some of the faculty and staff and students that pointed me to the software and how to create this project.